test the pH of pool water with red cabbage.
Can you really light flour on fire?
Really mix oil and water.
Find out on this week's episode of Chemistry Busters. Adam, what are you doing?
I don't know the pH of my pool water. I could dive in and die.
You're right. It's time for an experiment.
To the pool! Careful!
I'm going. Don't let it touch, don't let it touch you.
It's enough.
Back to the lab. Wait, Adam, how does one find the pH of a pool water?
Well, there are two ways we can determine whether the pool water is acidic or basic. We first can look at the pH scale. Numbers 1 through 6 are acidic. Number 7 is considered neutral, as you can see Jamie writing right now. Numbers 8 through 14 are basic, or in other words, alkaline. If it is an acid, it will always contain an H positive or hydrogen. It's very frustrating sometimes. If it is a base, it will always contain hydroxide or OH negative, as you can see here. There are two ways we can test the pH of the pool water. The first way we're going to use is we're going to use these pool's test strips. There's a key on the back that actually shows the color that the strip will turn for the pH. What we do is we just take one of these out, if I can, and you dip it right in the water like this. After that, it'll come out and you can look on the back and find the pH. So this strip shows that this and this match up. This indicates the pH level. So according to this strip, the pH level of the pool is 6.2, which is slightly acidic. The second way we can find out the pH is actually by using red cabbage. Using this technique, what you do is you put red cabbage into a bowl with hot water. You mash it up and you come out with this. This actually works as an indicator to figure out the pH of the pool. So what we do is we take some of the pool water and we pour it into this little bowl here. After we do that, we take some of the indicator and we just put it in here. The change of the color will tell us what the pH is. We see that it's a little lighter than this right here. So from that, we assume that the pool water is slightly acidic. Our conclusion from both tests actually indicates that the pool water is only slightly acidic. So it's actually safe for us to swim in.
Really?
Yeah.
Let's go!
Okay, let's go.
Why are you wearing the kitchen?
Well, I was gonna make some cookies, but then I heard that flour catches on fire super easy, so I didn't know what to do.
Really? Okay. I like fire and cookies. Let's go!
Liar.
Wait a second.
I have an idea.
Me too.
Yeah, it does.
So it works. It does work. Please, Adam. Dang it. Oh, now it all makes sense.
Blueprint?
Blueprint.
Okay.
There are 5 main factors that affect an object's reaction rate. Some main factors are the particle size and surface area. At first, we attempted to light a large pile of flour on fire. This didn't work due to the large amount of particles with a small surface area. Reducing the particle size provides more surface area, which creates more opportunities for the flour and fire to react. So small particle size means fire.
Yeah, but it doesn't mean you're gonna be able to catch your cookies on fire.
Okay, good.
Cookies?
Cookies.
Seems pretty lifeless.
Yeah. I heard somewhere that fish can swim in oil.
Really?
Yeah.
Let's try it.
Wait.
What?
We should probably put the oil in the water before we put the fish in it.
Good thinking. Get a good mixture going. I got you.
Mm-hmm. Hey, little guy.
You ready for this?
I'm ready. Careful. Gonna get you some oil. It's not mixing.
No. Let's
Try a bigger spoon, I think.
bigger spoon.
Yeah.
This one?
Oh, yeah, that works. Oh. It's just bubbling up.
What about a whisk?
A whisk! Yeah, that's good. Sure.
Let's take a whisk.
Alright, okay. This is good. It's not working.
Why isn't this working?
I don't know. We could blueprint it.
Let's blueprint it.
Okay. I don't even know how to blueprint this.
Why is it not mixing?
I don't know, there's a yellow layer on top and then the water's on the bottom.
Why would it layer?
It's like the oil is sitting on top of the water and I don't know why.
I thought it's...
Adam, this doesn't make any sense.
I know, I'm speechless. That's first.
That is a first. Well, looks like our little fishy guy's gonna be in some water for a while.
You can't mix oil and water because it creates a suspension. That means that the oil settles on top of the water upon standing because the oil has larger particles than the water and is less dense.
Oh, that makes sense.
We thought the water would be a solvent and the oil would be a solid. But the oil didn't dissolve into the water like a solid would do. So instead of becoming a solution, it became a suspension. That means that the particles settle upon standing instead of mixing in light into the water like a solution or a colloid.
So the water and the oil actually created a suspension, and that's why it wouldn't mix.
Oh, okay. I get that now.
Yeah. So, what'd you learn?
Well, Adam, I learned that oil and water just don't mix no matter how hard you mix it. It's always going to be a suspension.
Well, I learned a way to determine whether something is an acid or a base is actually to see if it has hydrogens or hydroxide in it.
You know, that's true. And what about the fire experiment? We learned that particle size has a bigger reaction rate when the particles are smaller.
Did you know that if you take a full glass of water and add salt to it, the water level will go down?
Nuh-uh.
Yeah. We'll test it next time on Chemistry Busters.
I don't even know, Jamie.
I'm Adam.
We said that.
This is really frustrating you. I mean, you don't even know your own name anymore.